All right, so let's talk about now how do you get your least squares regression line and identify all the parts based on some computer output. So here we've got foot length and height, and we've got a scatter plot. We can see it's linear going up, right? We'll talk about this residual plot. Actually, we'll just talk about this residual plot now. A residual plot is all I really care about is, first of all, if you took the residuals from each of these points, right? You draw a line, and you measure the residuals. They're all varying in length. Some of them are very small if they're right on the line. Some of them are negative. Some are positive. And you made another scatter plot, same x's, but instead you centered it around 0, and then you plot out all their residuals instead of their actual y values. And here's the deal. If it's scattered like this, you have an equal amount above and below, right? There's no patterns there. That means that a linear model is appropriate. That means using the least squares regression line does make sense. Okay, we'll come back to this in a second. I want to show you where would it make sense. If you did a residual plot, let's see, let me get to a different, like one that actually makes sense. So this one would be okay, right? Because you got some below, some above. One that wouldn't make sense. Here we go. So a residual plot like this would not make sense because see how we have a big cluster, not cluster, but we have like a obviously curved pattern here. It's not scattered. You have above out here and then below down here. That would be not appropriate. Same thing here. See how it comes up like this? The residuals. This would not be appropriate because we have like, especially if you have like a certain area where only like a certain interval where only positive dots or negative dots are in that interval, right? And they're kind of clustered off. That would mean that it's not appropriate to use a line for the model. But anyway, so that's residual plots. Let's come back to this and let's talk about these parts. Now, when a computer printout prints, stuff like this about two variables, about a scatter plot. You typically have two things on the left. The top is just like headers, right? They're just telling you what each thing is. But on the left, you see how it says constant and foot length? Well, constant is the y-intercept, and foot length is the x variable. And these are the coefficients or the things that would be attached to that. So the constant means there is no variable attached to it. That's the y-intercept. So 103.41 is the y-intercept. And then foot length is the variable, so the thing attached to that would be 2.74. We'll call it 2.75. And that would be the slope. So if I was going to write this out, I would write y hat equals the slope 2.75 times x plus 103.41. And it's plus because it's positive, right? If it was negative up here, we'd put minus. And of course, we define this. Y is the predicted, remember, you cannot forget that, predicted height. I could tell that from the graph, right? And the x value is the foot length. X is not predicted. That's the one we actually put in, right? Okay, so that's how you get your least squares regression line from your output. You look for the constant, that's the y-intercept, and the variable will be spelled out in words. That's the slope. We can also see s right here and r squared right here. We are not going to be using r squared adjusted in this class, so you can just ignore that. Later on in chapter 12, at the very end of this class, we'll be talking about what these mean. But for now, forget those also. But down here, the s, if we wanted to interpret the s, right, we'd say something like this. We'd say we can expect our prediction, our predictions of, or I should say any prediction, right, or a prediction, whatever, it doesn't really matter actually, of heights to using the least squares regression line to vary. That means it's going to be different, either positive or negative, from the actual heights by 7.95. Okay, so that's what we can expect to be off of. So if we make a prediction using this, we can expect it to be plus or minus about 8, right? Centimeters, I think it is. Yeah. So that's S. That's how you interpret S. How you interpret R squared is you would say, by the way, R squared, if I look at my thing, what is it, 48.6%? So I would say something like this. 48.6% of the variation in Y, but I'm not going to put Y, I'm going to put in heights, can be explained by, actually you can put X here, or you can put least squares regression line. I'm going to put the X value. It can be explained, and my pen's messing up, so put length. All right, so get these down. Make sure you understand these. The AP exam is very particular with the words, okay? Especially with interpretations, and you have a lot in this chapter already. We have to interpret slope, we have to interpret y-intercept, we have to interpret s, we have to interpret r squared, and you have to do so appropriately. So make sure you are studying those and you're kind of memorizing what they are and how to describe them or how to tell what they really mean, okay? And this is what I'm expecting. If you memorize these and just replace the numbers and the variables, right, then you're golden, okay? Just do what this says. Just keep this form and replace the numbers, the variables with the actual context of the problem, and you're good, okay? That's my advice to you, because if you do that, you'll get 100%, I'm sure. Thanks for watching, guys. Sorry this was a little long. I think it was a total of about 16 minutes, but this won't be due until, let's see, this will be due on Tuesday when I see you Tuesday, okay? Thanks, guys. Bye.